In the vast blue expanse of our planet, a paradox unfolds. We live on a water world, yet billions of people face a daily struggle for a single, clean drop. This is the story of a global crisis and the remarkable innovations that promise a sustainable future. This is the story of turning the tide. Our planet holds over 326 million trillion gallons of water. But here's the catch: 97% of it is saltwater, locked away in our oceans. Of the remaining 3%, most is trapped in glaciers and ice caps. What's left for us, for agriculture, for industry, is a tiny fraction of 1%. This precious resource is under unprecedented strain. A growing global population, rapid industrialization, and the escalating impacts of climate change are pushing our freshwater supplies to the brink. Rivers are running dry, lakes are shrinking, and underground aquifers, which took millennia to fill, are being depleted in a matter of decades. In places like Cape Town, Sao Paulo, and Chennai, the term day zero has entered the public lexicon. The terrifying day when the taps could run dry. The consequences are dire, from crop failures and food shortages to economic instability and conflict. The World Health Organization estimates that half of the world's population could be living in water-stressed areas by as early as 2025. We are standing at a critical juncture where the need for a new source of water is not just a preference, but a necessity for survival. The answer, for many, lies in the one place we have in abundance: the ocean. For centuries, humanity has dreamed of turning salt water into fresh. Ancient Greek sailors boiled seawater and collected the steam, a rudimentary form of distillation. But turning this age-old dream into a large-scale, reliable solution required a leap in scientific understanding and engineering. Today, two primary methods dominate the desalination landscape: thermal distillation and reverse osmosis. Thermal distillation mimics the Earth's natural water cycle. It involves heating salt water to create vapor, leaving the salt and other impurities behind. This vapor is then cooled and condensed back into pure, drinkable liquid. There are several variations of this process, such as multi-stage flash distillation, or MSF, where water is flashed into steam in multiple stages at progressively lower pressures. Another is multi-effect distillation, or ME, which reuses the heat from condensation to evaporate more water in a series of chambers, making it more energy. For decades, thermal distillation was the go-to method, especially in the energy-rich regions of the Middle East, powering cities that rose from the desert. But its high energy consumption has long been a significant drawback. Enter the game changer, reverse osmosis, or RO. To understand reverse osmosis, we first need to understand osmosis. It's a natural process where a solvent, like water, moves across a semi-permeable membrane from a less concentrated solution to a more concentrated one, trying to equalize the concentration on both sides. Think of how a plant's roots draw water from the soil. Reverse osmosis, as the name suggests, does the exact opposite. By applying high pressure to the saltwater side, we force water molecules through a specialized membrane, leaving the larger salt ions and other contaminants behind. This membrane is the heart of the technology marvel of material science. With pores so small, they are measured in angstroms, 100,000th the width of a human hair. The development of these advanced polymer membranes in the latter half of the 20th century revolutionized desalination, making it more energy efficient and scalable than ever before. From arid coastlines to bustling metropolises, desalination plants are becoming vital infrastructure, transforming landscapes and lives. Let's journey to some of the world's most impressive facilities. Our first stop is the Sorek Desalination Plant in Israel, a country that has turned water scarcity into an art of water management. Located just south of Tel Aviv, Sorek is one of the largest and most advanced reverse osmosis plants on the planet. It produces over 600,000 cubic meters of fresh water every day, enough to supply about 1/5 of Israel's domestic water needs. Its sheer scale is breathtaking. Thousands of membrane-filled pressure vessels work in unison, a symphony of high-pressure pumps and intricate piping. Advanced energy recovery devices capture the pressure from the exiting brine stream and use it to help pressurize the incoming seawater, slashing energy consumption by up to 50%. Today, desalinated water accounts for over 80% of Israel's drinking water, a testament to how technology can secure a nation's water future. Now, let's cross the globe to Carlsbad, California. The Claude Bud Lewis Desalination Plant is the largest in the Western Hemisphere. It provides a drought-proof supply for San Diego County, producing 50 million gallons of high-quality drinking water daily. The project was born out of necessity, Following years of severe drought that threatened the region's water security, its construction and operation represent a landmark achievement in American infrastructure, showcasing a commitment to diversifying water sources in the face of a changing climate. The plant not only provides a reliable water source, but also serves as a model for other coastal communities in the United States. Our final destination takes us to the Arabian Gulf, the epicenter of thermal desalination. The Ras Al Khair plant in Saudi Arabia is a colossal hybrid facility, one of the largest of its kind. It combines both multi-stage flash distillation and reverse osmosis technologies. This hybrid approach allows it to optimize energy use and production. The plant not only produces over 1 billion liters of drinking water per day, but also generates a significant amount of electricity, co-locating power generation with water production to maximize efficiency. Projects like Ras Al Khair underscore the critical role desalination plays in supporting economic development and population growth in the world as most arid regions. These facilities are more than just industrial plants. They are lifelines, symbols of human ingenuity in the face of environmental challenges. They demonstrate that with vision and investment, the ocean can indeed quench our thirst. Despite its incredible promise, desalination is not a silver bullet. The journey from sea to tap comes with significant challenges that we must address to ensure its long-term sustainability. The first major hurdle is energy consumption. While technologies like reverse osmosis have made huge strides, separating salt from water is an inherently energy-intensive process. Most large-scale plants are still powered by fossil fuels, contributing to the very climate change that exacerbates water scarcity. The carbon footprint of desalination is a serious concern that the industry is actively working to solve. The second challenge is the environmental impact of brine. For every liter of fresh water produced, roughly 1.5 liters of highly concentrated saltwater, or brine, are left behind. This brine, often containing residual chemicals from the treatment process, is typically discharged back into the ocean. If not managed properly, this dense, salty plume can sink to the seafloor, harming marine ecosystems, suffocating seagrass meadows, and stressing local marine life that isn't adapted to such high salinity. Finding environmentally safe and even economically beneficial ways to manage brine is a top priority for researchers and engineers. Finally, there's the issue of cost. Building a desalination plant requires a massive capital investment, often running into hundreds of millions or even billions of dollars. The operating costs, primarily for energy and membrane replacement, also contribute to a higher price for desalinated water compared to traditional sources like rivers or ground. This can make it prohibitively expensive for lower-income countries and communities, the very places that are often most vulnerable to water scarcity. Making desalination more affordable and accessible to all is a crucial piece of the puzzle. Addressing these three core challenges: energy, environment, and economics is the key to unlocking the full potential of desalination as a truly sustainable global solution. The future of desalination is bright, driven by relentless innovation. Scientists and engineers around the world are pioneering next-generation solutions to make the process cheaper, more efficient, and more environmentally friendly. One of the most exciting frontiers is the integration of renewable energy. Imagine desalination plants powered entirely by the sun or the wind. Solar-powered desalination is already a reality, with several pilot projects and small-scale plants demonstrating its feasibility. By directly coupling desalination facilities with solar farms or offshore wind turbines, we can create a zero-carbon water source, solving the energy problem and the water problem in a single, elegant solution. Innovations in membrane technology are also pushing the boundaries of what's possible. Researchers are developing new materials such as graphene and carbon nanotubes that promise to create membranes that are more permeable to water but even better at blocking salt. This could dramatically reduce the pressure needed for reverse osmosis, leading to substantial energy savings. Other novel approaches are also being explored, moving beyond the conventional methods. Techniques like membrane distillation, which uses a temperature difference across a membrane, and forward osmosis, which uses a draw solution to pull water through a membrane, could offer advantages for specific applications, such as treating highly saline industrial wastewater. Perhaps the most transformative vision for the future lies in reimagining brine not as a waste product, but as a resource. This concept is known as brine mining. The concentrated saltwater discharge from desalination plants is rich in valuable minerals, including magnesium, potassium, lithium, and even uranium. Developing cost-effective technologies to extract these elements could create a new revenue stream for desalination plants, offsetting their operating costs and turning a waste problem into an economic opportunity. This circular economy approach where waste is valorized, represents a paradigm shift in how we think about desalination. The quest for water is a quest for life itself. As our world changes, we must change with it, embracing new ideas and technologies to secure our most vital resource. Desalination is not the only answer, but it is an essential part of a broader strategy for water sustainability, alongside water conservation, wastewater recycling, and improved agricultural practices. It forms a powerful portfolio of solutions to ensure that every community has access to safe, reliable water. The challenges are real, but human ingenuity is a current more powerful than any tide. By continuing to innovate, invest, and collaborate, we can turn the vast, salty oceans into a source of hope, security, and prosperity for generations to come. The future of water is in our hands. Don't forget to like and subscribe for more.